Hi, my name is Lindsay Worthington. I'm a professor at the University of New Mexico, and what we're looking at here is called a seismic profile of our next drilling site. And what it is basically an X-ray of what the subsurface looks like below the ocean floor. So this white right here, this is all water. This line right here is the seafloor, and everything below this, all these different colored lines you're seeing, are the different mud and sand and rocks that make up the subsurface of the ocean. So what we use these for is, well, there's two things that we use these lines for. The first one is they help us actually decide where we're going to drill. So we want to drill in a place that's going to basically give us the most information that we can, and we have particular scientific objectives that are developed by using these seismic lines, and then we can go in and make a good decision about where we're going to drill. The other thing that these lines are used for is that when we drill, we only get data right in this one spot. And we're interested in processes that are taking place throughout the region. So when we get data in this one spot, we can use these seismic lines to basically correlate this data across a broader area.
Very good. And can you point out some interesting features? This is our next site that we'll be drilling, which is U1420.
U1420. Yes.
And can you point out some of the things that we'll be looking at that site?
Sure. So one of the primary hypotheses that we'll be testing here is when glaciers first advanced to the shelf edge. So about 1 million years ago, there was a change in the Earth's climate when glacial cycles changed from 40,000 years long to 100,000 years long. So right now we're in a climate cycle where glaciers advance and retreat every 100,000 years, more or less. And we think that coincided with basically the first time glaciers came out and they advanced all the way out on the shelf edge in the shallow water up in the Gulf of Alaska. So basically what we're looking at here is, here's all these rocks that were deformed and built up, and then you can see this surface right here, this purple one my hand is pointing to, it cuts off and truncates a lot of these lines that are right below it. And so what we think that this represents is when glaciers basically came out and acted like a bulldozer up here in the shallow water and basically pushed everything that was below it off the edge of the shelf. All right, so basically land is this way and the deep ocean is this direction. And here is the edge of the shelf. So this water is about 200 meters deep, and then as you go off this cliff, basically, water gets out to 4,000 meters deep. All right, so glaciers came out here and pushed all the sediment off the edge into the deeper water. And there are a lot of implications for when this actually occurred. And so when we drill down here, we're going to be able to date these rocks, and we're going to be able to know what time this happened.
Wow, that's really interesting. Thank you.
Yeah, of course, no problem.